Okay. Hello, hello. Can you hear me? Alright. Okay. I think I'm ready. Okay, so it's about time. Let me get started. Hello, this is Junichiro Horikawa, and this is a Houdini algorithmic live, a tutorial live for Houdini. Doing this weekly, and today this is 126th episode, and the topic for today is to create simulations for a so-called lenticular effect. And I already have some comments. Are you going to simulate the refractions or making shader that change with the angle? I am going to use the refraction procedurally or geometrically. And so I'm not going to create a shader, but instead I'm just going to do this more attribute way right, in Houdini, so that I might be able to use it for maybe a digital fabrication later if there's a way to precisely make the product. So that's my interest. So that's what I'm gonna try to do. And the things that I'm going to try to do is to create a lenticular lens like these, and doing the kind of effect, creating a lenticular like effect like these by changing the angle of the camera, by calculating the refraction based on the refraction index of the material. For example, using acrylic, the reflection index of the acrylic is about 1.49, so this is the result of using that index. And you can also change these procedurally. You can also change the amount of lenses per angle, or you can also change the scale, like the height of the lens itself. You can also change the depth of the lens, which will change how it will look like from the camera. So it'll be I think it's pretty interesting in terms of the physics simulation. It's really physics based simulation, so could be used for digital fabrication probably. So let's do this, and before going to do this, let's look at how lenticular lens work by looking at some of the website. Now this is one from some website that I found on Google search. It shows some nice illustrations. So first you create a lens, like you first have the lens like these, having some depths and some oval shape lengths like these. By looking at these lengths from the angle, since this lens has its refraction index, for example, if it is acrylic, the view angle when it's being penetrated through the material, it will bend based on diffraction. So the image that you're going to see actually is the goal of the bended direction. So in this illustration it looks straight, but actually it will bend a little bit based on the refraction index. And if the height is really big, if you have more height, then refraction, the bending will get greater. or the height of the lens itself also changes how the direction bends or changes. Okay, so based on those parameters, you can kind of control how the image looks like underneath. And by having a lot of images separated for each lens, like these, interlaced image, you can change the image based on the angle. In which angle you see, you can change what image to show. For example, from this angle, in this case, you see red image. In this angle, you see only a green image, and so on. So that's what I am going to try out here. The history is pretty old and it's pretty traditional way to create it. But if you do this virtually, it's not really limited to a straight lens actually, but it could also be like curved lens. So you could try almost any kind of shape using the same equations. So that might be interesting if it is possible to fabricate that. Well, let's see. So that's what I'm going to try to create, and hopefully you'll find it interesting. Okay, so let's do this from scratch. Today I'm using a 3D mouse so that I can smoothly change the 3D view of the camera, which works pretty well with this lenticular effect. So if you have one, I'll recommend it. Have some other questions. So if you just create the lens with ray tracing, it should work by default, right? Probably, yeah. In the renderings, it should work. Yes. Yep. So let's do this, because ray tracing is based on the physics, I suppose, so should work. But today I'm just going to do this a procedural way, geometrical way, instead of using shaders. Right? So practically it might not be really useful for most of you guys, but just for interest. Okay. So let's do this. First I am going to create a base grid, starting from a base grid. Okay. And try to create a initial lens layers first. So let's do that. I guess there are many ways to do this. Let me think what's the best way. You could change the rows and columns to change the number of lens, I guess. So maybe I could use these columns as the number of lenses. So let's do that. Going to create a new node. It's have a initial parameter defining how many lens you wanna have. Okay, let's say from 1 to 100, maybe 500 maximum. Okay. Let's copy this parameter to a column. Right, so this will be a number of lenses. Now for the rows, you could specify any numbers. It's just related to the resolutions of your final image. So I'll set it to 50 for now. And come back later to see if it's gonna to see if I need to raise this up a little bit. And next thing I need to do is to make each primitive rounded up, like an oval shape. So let's think what's the easiest way to do. I mean, just by having a circle placed in here or tube shape placed in these primitive area might be the easiest way. So let's just do that. In those cases, maybe I can set the rows to 2 so that I have only a single rectangles per lens. So now I could use a cylinder or tube shape. Okay. And let's try to copy this tube to each primitive areas. So in order to do that, you need to know the center of each primitive, the direction, and the diameter. Okay, so let's calculate that. So that has to be done per primitive. I am going to use the primitive wrangle. And center info. Okay. Let's create some attribute to this. Let's first create a center point per primitive. So that is int pt accessing to a at p, adding 1 point at p. At p is the center of the grid or square. I mean the rectangle, and then you could remove the original rectangle. Like that. So now you have points. Now you also want to get the width and the depth of this lens. The width can be used as the diameter, and the depth can be used as the z size. Okay, so where can we get that? We could actually go back to this parameters and calculate it by dividing those size, the original size, by these. So let's do that. I'm going to make one parameter diameter, and the depths, or well, I'll just call this depths. Okay, first of all, the depths is pretty easy because it's just 10, and since I was splitting columns, I think this value is the length, isn't it? Yeah. So I'm going to copy this value here to the depths. Okay, for the diameter, I could just divide this value by a number of columns. Okay, let's make sure this is correct by making the lens size really small, like 4 or 5, so that this size has to be 2.5 if you have 2 lenses. Maybe it's you need to subtract this value by 1. Let's check. Yeah, so it's not 2.5, so I think I need to subtract this by 1. Okay, now it's correct. Alright, So now it should be related to the lens numbers and the size of the original grid. Okay, now I have diameter and the depth. I can use this as a scale attribute. So I'm gonna create a scale vector value. Then for the x, I'm going to set it as diameter, and for the height value, the height value can actually be related to the diameter, I guess. So for now, I'm going to say set the same diameter value, and for the z value, I'm going to use the depth. Okay, now let's apply this to a point by set point attrib scale, which can be used with a copy to sop node. What was the point name? PT. Alright, and let's check the point attribute. So I have scale like that. Now let's go back to this tube. Let's see. Okay, now I also need to specify the direction for this for the orientation of this tube. So let's set point attrib normal. Not sure which way is the correct direction, so for now I'm going to set it to z direction. Probably I might need to change it. Okay, so I have the points with the scale and the normal. Now it's time I try out copy 2 points. See if it's gonna work. Okay, something is obviously wrong. Probably the direction is wrong, so let's change this to a x or y. I don't know, I'll try with the x first. Yep, wrong. How about these? Okay, the direction is correct, but the size is wrong, so let's change this one to a depth, this one to a diameter. Okay, now it seems to work. Alright, and I only need the top half of the tube, so let's make this half-sized. First of all, I'm going to make this as a even number column. And how am I able to split it into 180 degrees? Maybe there are no parameters for that for tube. Okay, then I'll just use clip like this. Konbanwa, everybody. Okay, so like that. Now I have a rounded lens shape like these, and I also want to control the overall height of these lenses so that it will affect how the direction refract or bend when seeing through these lenses. Also, I also want to change the height as well. Maybe that I could do that later, but for the depths of the lens, I could actually do it here, which is related to either this one or this one. Let me try with the Z one. Okay, so this Z, by changing the scale of the value, you could kind of control how high or how steep the lens is. So I'm going to create a parameter here. How do I call this? Lens roundness. I don't know. Okay. So it has to be more than 0 in order to have some bend, but could go over 1 as well to have more steep curve. I mean, physically, you might not find a lens like these, but in the simulation, anything is possible. So let's just do it. Yeah, looks good. So let's have this promoted to the controller node. All right. What else? Okay, I think that's fine. And next, you might want to change the height. Let's assume that this is placed on the ground, and you might want to have some space to the end of the edge of these lens to the ground, so you might want to raise these lenses up a little bit. That also affects how it bends, how the view direction bends. So let's just give a transform node and let user decide how much they want to raise up the lens. Okay. So let's have that as a parameter. Okay, and copy this, paste it, not here, paste it here. Okay. Right. So in terms of the lens, this is all you need to do, and you might also want to divide these lenses so that you can set different colors per vertices. The more res you have, more high res image you get as the final result. So it's up to you. You just need to increase the rows here in order to increase the resolutions. For now, I'm going to limit this to low number and come back here later to have more high res image. So this could also be a parameter you want to change. So let's give the rows is vertical resolution, and the column is the lens resolutions, or the roundness resolutions. Okay. Alright, so in terms of the lens that I want to try out, I'm ready. So it's now you create a image underneath to use it for a simulations, lenticular effect simulations. So the things you need to do is to create, decide how many image you want to use in order to change based on the direction you're looking at this lens. Could be 2, the minimum could be 2, the maximum could be any number. So let's have that parameter. image number. And well, let's set the minimum to 2. Okay, I have a comment. I have a question from Soto Monte. Sorry if this is usually asked, but how are you moving the camera? So I am using a 3D mouse. The maker is 3D Connection, and by using this 3D mouse you could like smoothly change the camera just by moving your 3D mouse like these. So it's a lot better than using a single like 2D mouse in terms of changing the camera view, but it's a little bit harder to control as well. If you get used to it, it's pretty nice. Okay, so let's try to create the image underneath. So I guess it could be interesting. It would be interesting if I could just create some animated image per divided image. So for example, the pig looking at the left side, pig looking at the forward, pig looking at the right side, and so on. By having those similar image, you could create a smooth animations if you have tons of split or tons of divisions per lens. So let's create that kind of animated image. So let's do that. So in the example that I made previously, I used pig head, but for this example, let's try using different test geometry like rubber toy. It's no difference. So first thing you might want to do is to define the direction, from which direction you want to create the image. So probably I want to create the front side of the view and rotate this like these to animate. That might be suitable for a lenticular effect as well. So in order to do this, the image you want to have is this view, but the grid that I have is on XZ plane. So I'm going to rotate this rubber toy so that it will align with this grid. Okay, so first I am going to rotate this. Do I X negative 90 degrees? Okay. Let's also scale this up a little bit. If you want to automatically scale this based on the base grid, then you can do this expression way or using wrangle. Either way, let's use wrangle way. In order to do that, you need to refer to the original grid. So connect that to a second input, and what you want to do is to get the center of the grid, which can be get by Bbox center. You also want to get the size of the bounding box from the second input, so get Bbox size. Okay, having those two, you could actually scale this to a correct amount of value. So let's do that. First, I am going to calculate the current centroid of this rubber toy. let's call this C-sen, S-sen, using the same functions for the first input. Now, first thing you want to do is to move this to the centroid of the grid. So create the vector value, which let's call this T as a target and this as a source. So the direction, the moving direction is T center minus S center, so center. And by moving the point attribute by the move direction, first it will align to, it will move to the centroid of the grid. Okay. Next you want to scale this, so the next thing you want to do is to get the source bounding box size, which can be retrieved by using the same function here from an input 0. Now that you have this value and the target value, you know how much you need to scale these up in order to fit with the bounding box. So the scale ratio can be calculated by T size divided by S size. Now in this case, X, Y, and Z coordinate will have different size, so you need to choose either X, Y, or Z in order to uniformly scale. Now you could just get the smallest, I guess. The largest might go off the boundary, so I'll just choose the smallest in this case. So the smallest scale out of X, Y, and Z coordinate of this scale can be retrieved by using min function 2 times. First compare X and Y and get the minimum, then compare the value with the Z value, so that you get the minimum out of 3 coordinate. And you could use this to scale the point, but before doing that you need to move the centroid of this geometry to this to the 0, 0, 0 positions, but this grid is already at the 0, 0, 0 position, so I don't think you need to move this at all. So you can just multiply the current point positions with this minimum scale. And where did it go? Okay, I realized that the Y scale of this grid is 0, so you don't really need to use this scale Y. I realized. So just need one minimum. Alright, that'll fit the grid. And you might want to have some margins. So in order to have some margins, you could increase the source size here by some amount. I don't know how much. Let's call this offset or margin. Like that. Okay. Let's make this 0.2 for now. Okay. Now, now that I have a geometry aligned to a grid, let's also make some animations. Or maybe not. Let's try to... Actually, I need to test if it still fits when I rotate this rubber toy. If I animate this, oops, using, in this case, Z axis, I want to make sure this still fits inside the grid. Okay, looks good. Okay, so I guess I want to start from when the angle is 90 degrees and then gradually change this to a negative 90 degrees. Okay, so I'm gonna make this as a starting point. Okay, now next thing I'd like to do is to using the value that I have here, how many like grid or how many image I want for each lens. This will also be the amount of animated object. In this case, if the number is 3, then you have left side, front side, and the right side. Okay, so to make those image per to make each image, I am going to use a for each number. I might just be able to do this all in Wrangle, but might be not. It's not really clear what's going on inside the code, so by using these for each loop, it might look a little bit clearer what's going on here. It's a bit slower, but in order to prototype, I think it's better. Okay, so what I'm going to do is I am going to try to use the original grid here to scale for each loop. In the first loop, I'm going to scale each grid and place it somewhere on here. And on the second loop, I'm going to place it right here with the 1/3 scale. And on the last loop, I'm going to place the 1/3 scaled grid here. So I'm going to connect the grid here. Then first, let's decide the scale. Using, I don't know, it could be primitive wrangle or it could be point wrangle. Let's just use primitive wrangle. Okay, and let's connect the for each count node to the primitive as well. And then let's call this size. How do I split size? Split image size. Okay. And the number of loop has to be equal to the number of splitted image, so per lens. So let's copy this, paste it here. Okay. So the iteration value coming from this meta node will be 0, 1, and 2 if you look at the detail, these one. So I could use this to define where the primitive should go. Okay. Okay, so let's first, and you could also get the number of iterations, which is also a number of split, accessing the num iterations attribute. So let's have two attributes coming from the second input. One is the iteration, which will be 0, 1, and 2. and the number of iterations, which will be 3 in this case. Okay, now let's scale this first. So the scale is 1 divided by the number of iterations. So CSC is 1 divided by num iterations. Now you want to access to the each point of the primitive so that you can actually scale it. So and one thing that I need to do before scaling it, you need to separate separate the point which is currently being connected at each point. Meaning I need to make each point unique, something like by using unique points, so that you can actually separate the grid. So previously the number of points was 110, but now it's by using a unique point it becomes 216 points, and you could separate the grid like that. Yeah. Without having unique points, you're going to just deform the primitive, so this is necessary. Okay. So let's scale this. In order to do that, let's access to the point for each primitive by using prim points. Loop through all the points. Accessing to the point number. You could also get the point position. Now, in order to scale, you first need to move this point position to a... You need to move this based on the pivot center of each grid. And for each grid, the pivot center could be at the corner, one of the corner of this grid. And in this case, I might want to make this as I want to make the left bottom corner to be the the pivot center for the scaling. So to do that, I need to kind of retrieve this point position here, which I could do that by, let's see, the easiest way is to get the boundary box of each primitive and just get the minimum positions, I guess. So I'll just use, for each primitive, I'll use a function called get Bbox, and in order to specify which primitive to use for the minimum and maximum, I'm gonna use this primitive group. So I2A, convert the current primitive number to a group. I'll get a minimum maximum for each primitive. Right. Now that I have this minimum value, I'm going to use this as a pivot center for the scale. So in order to do that, first subtract the position for each primitive with the minimum, then scale the x coordinate of the position by the scale value that I created. Then move this back to the minimum position. Now let's see. And I need to update the current point position using setPoint attriv. To the point with this newly created point position. Okay, where did it go? I think I did something wrong here. Let's see why. Let me check if I'm getting, first of all, if I'm getting the right minimum value. So in order to check the primitive, let's see. The minimum, yeah, I'm getting the minimum value correctly, so that's good. Right, now let's see if I'm getting the scale correctly. Scale is 0, so this is wrong. Okay, so this has to be 1 because I'm getting the value from the second input. Okay, so that was the mistake. Okay, now the value seems correct. And hopefully I am getting the right scale. Okay, so each grid has been scaled 1/3. Now it's time to move the grid based on the number of iterations. If the iteration is equal to 0, it could stay here. If the iteration is equal to 1, it should move to the center. If the iteration is equal to 2, then it should move to the right side. So iteration is this value, and the amount of movement can be defined by this SC here. So after scaling, I could add an X value by a SC multiplied by the iteration. There we go. And as a result, if you go out of the loop, oops, something must be wrong. Okay, let's go back and see what's wrong here. The original grid looks like, okay, so it's obviously going out the boundary, so something must be really wrong. Okay, so actually this is just a scale, and this should not be the amount of the movement. The amount of the movement is actually the scale multiplied by the width of each lens. So I need to have that information as well, which can be retrieved somewhere around here, which I already have it calculated here. So I can just copy this parameter and refer to that information using an input. Okay. Paste that. Okay, so this is the diameter, so I need to multiply the diameter as well here. Okay, now let's go outside the loop, and now I have 3 bars as one set per lens. Okay, and should work even if I change the number of image per lens like that. Okay, that's good. Okay, so I'll just continue with 3, but later I'm going to try to see if it still works with larger numbers. Okay, so the split for each grid is done. Next thing is to transfer the color informations from this geometry to the grid. And in order to transfer the color value, you could either transfer the color to a primitive attribute or a point attribute. Either way is fine. In this case, I am going to transfer the color to each primitive, meaning wait a minute. Let me think which way is better. In this case, maybe for the flat image, it might be better to transfer the color on a point, probably. So I'll just do that way. So in order to do that, let me think how I would do. Let me see. The things that I need to consider is whether I want to make high res in terms of each bar in order to transfer the image from those animated object. Well, for now, let's just use one grid as a split number for a horizontal direction. But later I might wanna make it more high res in order to get the final image as high res. Okay, well, but at least I do need to split this vertically because currently I don't have any point on the vertical directions. So let's do that. To do that, well, what's the best way? One of the way is to use divide node, and I think I could do this right here, and instead of triangulating, I could use this Bricker polygon to decide how many like offset that I want or divisions that I want vertically by changing, in this case, a z direction here. So if I make this smaller, you have more split vertically like that. You could also do the same things for the x direction. If you make this smaller, you have more split on x direction as well, like that. So these could be parameterized, I guess. Let's do that. Let's go to the controller. This is really not an important parameter, but let's have it. Vertical imageless, which is a bit confusing because I already have it here for the lens. So let's make sure this is for the lens and this is for the image. I'm gonna use a separator here. For the vertical one, I'm gonna name this lens. Okay. And for the image one, I'm gonna name this image vertical resolution. From 0 to 1. And same for the horizontal. So I'm gonna duplicate this. Okay. All right. Okay, hello, damage control. since we can use Python code, can we get a remote connection to WSL server to create some crazy AI-based art? Like sending some point groups or renderings to AI to detect face or poses. Yeah, I think it's totally possible, for sure. Yeah, I haven't tried it, but I could see it's possible. You might need to have some event set using Python in order to trigger some functions based on those events, but I think it's totally possible in any software. Okay, so let's copy this. Going back to the divide, copy the vertical to here and copy the horizontal to here. X. Okay. Now I'm just gonna change the vertical resolutions for now to have bunch of grids, points. Okay. Now let's transfer the color to this strip. Think in order to transfer the strip, I could just, I don't know, refer to I could just color each grid this square like a pixelized image. Okay, so shall we do that? And to do that, you could use a primitive wrangle, accessing to those each strip, and what you want to do is to transfer the color which is coming from this rabbit-toy to here. Okay. Now to do that, you kind of need to make this also animated based on the iteration number here coming from this for each count. So I could either use transform node or point wrangle. Either way is fine. If I want to use transform with an expression, what I need to change is this value here. So first I can access to a for each count iteration value. It should be from 0 to 2, and then I want to remap this value to in an angle from 0 to 180 degrees or minus 180 degrees. So what I could do is to fit this value, remap this value using fit function, which is always start from 0 to the maximum number of loop, which can be copied from here. So let's paste this. -1 is the maximum for the iterations, and then remap to 0 to 180 degrees. Okay. That'll do, hopefully. Currently the iteration number is 0, so should be correct. And if the iteration number is 2, then this should rotate this rabbit toy to the right side. Okay, so it is rotating, so it looks fine. Now that the rabbit toy is rotating based on the iterations, you just need to copy the color informations to the strip. Now this is the tricky part. because what you want to transfer is the color coming from the texture, not the color attribute in this case. If you look at the point attribute or the primitive attribute, you see that there is no color attribute to this rubber toy. So you kind of need to get a sample of the texture applied to this geometry, convert it into a color value. So to do that, you need to use a function called color map. I'll show you how you use that. Let me search for the functions. That's more related to the shader codings, but you could also use it on SOP context. So it's pretty handy. So this is the functions that I'm going to use. By using this, you can sample the texture file using UV, and as a result you can get the color value, or with the alpha, but I don't need the alpha, so I just need the vector value. So if you know the path to the texture file, you could actually get the color attribute using UV. So that sounds interesting. So in order to get the color informations from this rubber toy, you need to know two informations. One is the file path to the texture, and the UV to the specific point position. The UV is easy. You just need to look for a UV attribute which is stored on vertex in this case. So this is the one you need. And the other informations, the texture path, file path, can be retrieved from this shop material path. Okay, which leads to a shader direction. So let's first look at this shader, which is inside the test geometry shopnet toy shader. So if I double click here, there's a shopnet and there's a toy shader. And probably most of the materials are using principal shader. So every principal shader has this parameter like texture here. And this is the actual texture file path of this material. So what I want to do is to refer to this channel, parameter channel, from the shop material path. Okay, so let's look at the name of the texture, which in this case this is locked, so I cannot really look at how the parameter name looks like. So just gonna go to the material and create one principal shader, check the edit parameter interface, and check which parameter that I need to retrieve. And probably this is the one. So under the base color there's a texture, and the parameter name is called base color texture. So this is the channel, this is the parameter that I want to refer to from the principal shader in order to get the file path of the material. Okay, so remember that, base color under texture, was it? Yep. Now going back to the geometry node, I am going to get the actual texture file name using those information that I just got. Okay, so first thing first, let's get the first I need to I need to get the corresponding point position for each grid above. So if I'm looking at this grid, then I need to get the corresponding color at this position from the rubber toy. The first thing I could do is to get the corresponding point position of at this point, which is somewhere around here. And you can do that by using function like intersect. So let's do that. So first create the output vector value like intersected position and UV. Now be careful, this UV is not the one that I need in order to in order to sample the texture. This UV is a primitive UV. So I'm gonna name this PUV so that it's less confusing. Prim UV. This prim UV is different from the texture UV, so that's one thing you need to be careful of. Now let's calculate the intersections. Intersect, starting from the really high positions and make the ray underneath. So intersecting to the second input, starting from the current grid point position plus really high positions like 1000. I'm not sure if this is enough. And then make the direction, which could be a negative y direction. It could be more than 1000, so 10,000. And get the intersected positions and the prim UV. Well, actually, I don't want to use prim UV as a name because this is the name of the function as well. So I'm gonna name this PRUV. Okay. Now hopefully I'll get the intersected point. Let's test. Let's create a point position, a new point at an intersected position. See if I'm getting the point on top of the surface. And if I enable these, yeah, I am getting. Okay, so that looks good. I am getting the intersected point positions. Now what I want to get out of this information is the shop material path, primitive attribute, and the UV. So first let's get the UV. UV can retrieve by using prim UV function, and the primitive number is the information that I want to get is the UV, and the primitive number is intersected value here, and the PR UV is the associated primitive UV in order to sample the value. I also want to make sure that if the intersection is available, there is a chance that there is no intersection. So in those cases, I can just make the color black. Okay. Else, make the color black. Okay. Now that I got the UV value, I also want to get the shop material path. By accessing to the primitive attribute from the second input, shop material path at intersected primitive number. Now I'm gonna make sure this attribute name is correct. Let's check. So shop underscore material path. Okay, it's wrong. Shop material path. Okay, so this should be the correct attribute name, and hopefully I'm getting some information here. Let's check. I'm gonna check it by copying this value to some random attribute. Okay, yeah, I'm getting here. So this is where I am getting the intersection. Let's also check the UV. Okay, so I'm also getting the UV as well. Okay, now it's time to get the file path for the texture for this material. So in order to get that, you can use so this is the path to the node, and if you look at it carefully, where is it? If you look at the material shop path, this is the node path. So by adding what's it called? Slash with a name of the parameter, and that was color base color texture. You should be able to access to the file name of the texture. So let's try. So string texture name text is equal to chs, which is in order to access the string parameter, is shop material path plus slash base color texture. Let's check. I'm gonna make an attribute called A. Let's see if I'm getting any name here. Well, there you go. So this is the file name that I want to access, and this is by using these file path for the texture, you can use the function called color map in order to sample the color. All right, so let's do that. How do I use it? Color map, the first parameter is the file path, and the second parameter is the UV. Okay, so cd is equal to color map and texture file path to UV. And I don't need this anymore. Now let's check. There you go. So I have successfully retrieved the color information from the texture information. All right, and looks like this as a final result. Interesting. All right, so as a setup, I think this is fine. All right, so next I am going to actually calculate the refraction by changing the directional view together with the roundness of this lens to pick up the color underneath, which is these. Okay. Okay, so let's do this. So the and I want to transfer the color to the lens itself. So probably I need more resolutions to the vertical direction. Maybe I can go back here, increase the maximum number of the vertical lens here to have more divisions. I don't know, I mean I could go with 50 for now and make this larger later. Okay, so I could transfer the color either to a point attribute or to the primitive attribute. I mean, either way is fine. In this case, let me check what I did previously. So I think I used the point to transfer. So I'll just do the point transferring. I'm going to transfer the color to each point for this lens. Pick up the color from the bottom plane, which has these information. So connect this here and connect this to the second input, and this is the actual lenticular effect equations that I'm gonna create. Okay. Make sure this is at the same positions. Yep. Alright, so another information that I need is the current camera direction, okay, in order to calculate the refraction. So, and bend the direction, the view direction. So let's create the camera view. I'm going to click the camera with an option, okay, and make this locked so that the camera will be moved with the view. Alright. Now, let's get this directional information. There's two ways to do that. One way is to use these, copy these value and use it to estimate the direction, or another way is to get that informations by from the camera matrix. So either way is fine. Or actually the direction itself is actually the direction from the camera to each point on the lens. So if you just get the camera positions, and that's all you need to have. So in those cases, maybe you can just copy this translate value, which is the easiest, I think, and use it here. Create the vector input and copy the value here. There you go. Okay, so having this camera positions, you can also calculate the camera view, camera direction, by subtracting the current point position on the lens with the camera point position. Yeah, let's also normalize this so that the size will be equal to 1. Alright. Now that I have this camera directions, it's time you calculate the refraction at each lens. By calculating the refraction, you can estimate the bended direction when your camera direction penetrates or touches the lens. The direction should bend to some other directions based on the angle of this lens and the depths. I mean, depth doesn't really matter in terms of the direction. It's just based on this, the curvature of this lens. And in order to calculate the how much it bends, or what's the final direction for the refracted directions, you could actually use a simple functions coming from the Vex. I found out that there is a function just for the refraction called refract. So you could just use this to get the bended directions using the refractions. Three informations you need. One is the direction of your camera, one is the normal of the lens, and the refraction index, which will be tied to a material. If you're using acrylic, then the value is about 1.49. So let's create a parameter called refraction index. Refraction, I'll just call this index here. Okay, and let's make this 1.49. Consider this is acrylic. Okay, make this maximum to 2. Now, next, I also want to get the normal direction at each point of this lens. So in order to have that, probably need to calculate the normal beforehand. Let's use point. Let's check. Okay, looks good. So I'm going to use this direction to calculate the bended direction, bended camera direction. Okay, so let's go back and calculate it using this handy function, shall we? So the actual bent direction is refract camera view and negative normal direction, which is negative at n. And you're going to use this refraction index to calculate how much it bends. Okay, now let's check this direction. I am going to apply this to a bent direction. Let's see how it looks like. Let's visualize this using marker. With the vector. Now I don't want to change the camera view, so I'm going to create another view here in order to see. Okay, so am I seeing any views here? Okay, let's make sure this, okay, I haven't applied to the attribute yet. Somehow. Okay, now, okay, I kind of wanted to see here, but not seeing here, just seeing here. Oh well. But I can see that the direction is being bent, hopefully. Not sure. It's a bit hard to see. Okay, well, anyway, hopefully it's going well, and let's check that by using this direction to pick the color underneath, which is these colors here coming from this grid. Okay, so using these bent direction, you're going to calculate the intersected point from each lens point. Pick the color. Pick the corresponding color using the intersected information. Okay, so let's do that. So now I have the bent directions. You could calculate the intersection. In order to use the intersections, you need to have intersected point positions, primitive UV, and intersection can be calculated by intersect to the second input, which is the grid image, and intersect from the current, starting the ray from the current point position of the lens, then to the bent direction with enough amount to trace, get the intersected position and UV as an output. And what you want to get is the color informations at the intersected point position, so you could use this PRUV together with the inter to retrieve the image color, the color informations. So if intersection is available, then the color information is prim UV, second input, get the color, and actually I realized that I am looking at the primitive colors, so I can just use prim with an inter. I don't really need to use a UV in this case because the color is applied to each primitive as an attribute. Alright, so does it make any change? Not yet, somehow. Let me try to reset this just to make sure. Okay. And where does the code go? Okay. The code is gone for some reasons. Gotta rewrite this again. Where was I? So enter. This happens a lot for me. Code just disappears. I don't know why. Intersect, second input, starting from the current point positions, bent direction multiplied by 1000 interpositions, and UV. Wait, oof. Something is off here. It's been disappeared again. Let me reopen the file. Save it. Override it. Okay. Let's try. Let me rewrite this again. I don't know why it disappears. So vector interposition, PRUV, intersect, second input, starting from the current point position, bent direction multiplied by 1000 intersection positions BRUV. How's this? Oh wow, just disappears. Why is that? I have no idea. How's this? Am I doing something wrong here? I am not sure. Let me copy this, create another point wrangle, paste it here. Okay, that's gonna try to recreate the same situations here. Vector interpositions, BRUV. Okay, now this seems to work. Not sure why it didn't work last time. I guess I need to copy these values here as well. That might have been the reason, maybe. I don't know. Because of the camera positions, maybe? I don't know. Let's try. Going back to the camera again. Copy the translate. Paste it here. Write something. Okay, it doesn't disappear, so maybe that's not the case. Well, intersection, intersect, second input, starting from at P, bend direction multiplied by 1000, intersection positions, PRUV. Oh. Why? Let me try deleting the camera positions. Huh. This is so weird. Okay. I have no idea what's going on. Intersect. Okay, in this case, I'm just going to use the external editor. So yeah, this should work because I have this apply button. Inter is equal to intersect. 1 position bend. Okay, this is like 5th times I'm writing the same code. PRUV. Okay, apply. Cool. Now let's get the color. If intersection is available, then change the color to the primitive color at intersected primitive number. Else I could just set it to black, I guess. There you go. Okay, now it already should have the effect of the refraction. By changing the camera view, you see that things are happening. The image is happening to change, started to change based on the camera angle. Alright, and by changing those parameters, like the number of lens, or the height of the lens, you could see how it make a difference. This is the resolutions on the vertical direction. And this is the roundness of the lens. So if you have small roundness, you're seeing more gradual differences between the image. If you have high lens height, you're seeing more crisp split between the image. Interesting. And if you have more lens numbers, starting to have more gradual gradation, so based on those numbers you might need to change those parameter to corresponding value to have the right amount. The lens roundness or the height. Height also changes how it views. Cool. And by changing the number of images from 3 to more numbers, you should be able to have more gradual animated view. Now in this case I might need to change the height a little bit more, or the lens height as well. A little bit higher in this case to have more crisp image. You need to find some good balance in order to have the smooth animated effect. So I think this is practically useful in order to find out the best parameter for the physical object as well. Because this small amount of value will drastically change how it looks like. So probably if you can fabricate the real lens precisely, then this simulations could be useful. Just as a dream. Maybe in the future it might be possible. Well, at least this is interesting. Seeing all this different effect by just changing the height of the lens and the depths, isn't it? You could also see some kind of a moire effect. Maybe I need to hide the wide view. Alright, looks more like it. Okay, so this is how kind of a lenticular effect works. Let me know if you have any questions or anything. And probably you could just change this rubber toy to something different, like pig head. Get the similar effect. Like that. In this case you might need more offset or margins to fit in the grid. And I could also coordinate the parameters a little bit so that I have more crisp image per angle. It's pretty hard. Really hard to find the right balance. But it's totally worth it. Pretty interesting. Really looks like a real lenticular effect, doesn't it? is there anywhere we can see your own creations? Well, I am doing a self work together with an artist graphic designer called Fukaji-san, called as dgraph. So if you could check the work there, you could check the work here on dgraph here. This is a design studio by a Fukaji-san, Hiromasa Fukaji-san, a graphic designer, and me as a algorithmic designer. We're doing some digital design work applied for physical design, like plotter drawings. This is one of the examples we did, using plotter design to draw an algorithmically created images like nature inspired shape, or these. We also tried creating pot inspired by the voxels and so on. So please check it out if you're interested in this kind of stuff. Okay. Well, I guess this is it for today. Let me know if you have any questions or feedbacks. I could also try, if you're interested, I could also try it using like curved slit or lens for trial, which I haven't tried previously. Currently this is more physical based vertical lens, which is already available commercially, but the curved lens might not be available in the physical situations, but you could do the simulations in the virtual space, so it might be interesting testing these out as well. So let me know if you're interested. If not, I'll just finish this live here. Meanwhile, I am going to organize this a little bit. Okay, let's call this shape parameter. Copy this one here. What else? I think I have already transferred all the parameters. So I guess this is it. I think I'm not seeing any comments anymore, so let's just finish it here, shall we? Well, thank you for joining, and I'll see you next week sometime. Alright. Let me just try to find out some nice parameter for the final screenshot. Okay, well, as always, I am going to upload the file to the GitHub. I am going to paste the file URL to the video description page of this video live stream so that you can download it, and together with an archive. And I'm also doing the Patreon page myself, so if you are interested in this kind of stuff, if you would like to support me, I'll be really appreciated. Okay, so that's it. Thank you very much for coming. Hopefully you're having a nice day, nice weekend. All right. Okay, so good night and see you next week. Bye bye.